I have no relevant disclosures for this presentation. I do want to highlight the fact that there were an enormous number of people involved over the past 2 years in this endeavor. I want to specifically acknowledge Anat, who's really led the field in terms of trying to sort out this concept of antibody strength, particularly from the clinically relevant aspect, and also my colleague Maria Meneghini, who's not here today but has worked very closely with us from Barcelona, and I will acknowledge the others as we go through. So let's get to this. So in terms of assessing the antibody strength, first is defining the problem. So it's been increasingly recognized over the past decade that there's really limited standardization in our approach to reporting antibody characteristics. And so as a result, heterogeneity limits interpretive value. And of course, this heterogeneity in how we're reporting is further augmented by the fact that human nature is essentially very heterogeneous, and our patients are not mice, and therefore it adds an additional layer of complexity to our interpretation of what we read. And so there's really a need for a way to reproducibly categorize antibodies into weak, moderate, strong, and very strong. And this led to the STAR 2022 recommendations for reporting standards. And I'm going to just focus a little bit here on the desensitization trials, and it's all been very well reported, but I want to highlight a few key aspects. So their first recommendation was that CPRA should be determined at baseline and following any intervention as well as after transplant in titers. And they specifically suggested a minimum of 2. And I think it's important to note that they suggested this not only at baseline and after treatment, but also in long-term follow-up to examine durability. Second is that the number of unacceptable antigens should be documented before and after an intervention. And importantly, transplantation rate should not be used as a primary endpoint in any case, except for patients who have a living donor. And so for living donors, there's a set of secondary outcomes recommended, including change in cross-match from positive to negative. But they also highlighted the fact that we should collect the same information for those patients so that we have a larger repertoire of data that can be more widely interpreted. And finally, they acknowledged that these recommendations need to be validated, and that's what I'm going to spend the second half of this talk on. Just to give a little bit of background and get everybody on the same table, in terms of using serum dilutions to define antibody titer, a couple key principles. So the single antigen bead assays that we use operate in a limited range of antibody strength, which is sort of the intersection between molarity and avidity, if you will. Bead saturation limits the interpretive value above this threshold, and that's just basically saying what we already know is that if you have a MFI of 20,000 or 28,000, this can imply a very different strength between two individuals. And diluting serum can at least partially overcome this limitation by sort of effectively bringing these antibodies of different strengths into the linear range, or at least below saturation of the single antigen bead assay. And these dilutions can then be used to define the antibody's titer, where the titer is defined as the dilution at which an antibody crosses a predetermined inflection point, which has commonly been used as an MFI around 2,000. So the titer then can be used to calculate CPRA. So just to sort of put this into a little bit more of a visual over the next few slides, this is just sort of a pictorial of a dilution series, and if you define a threshold of positivity of an MFI of 2,000, what we're talking about here is that you have a 1 in 4, 1 in 16, 1 in 64, and 1 in 256, sort of a twofold dilution series, and then you can actually interpolate the titers between them. And again, just to highlight the STAR 2022 recommendation is to perform at least 2 titers, and ideally to try and identify the inflection point of the CPRA. So, okay, Now, just to talk a little bit about bead saturation, again, this is really just to get everybody here on the same table and to try and develop some kind of a nomenclature so that we can be talking about the same thing. As you can see, there's this plateau out to a titer of about 1 in 64 for this representative antigen, while this other antigen, A69, has a much more linear trajectory in dilution series. And so this is just really saying two antibodies with very different strengths can have a similar MFI in neat serum. Diluting the serum then unmasks the differences between these two antibodies, and perhaps you can see this best at a dilution of 1 in 64, where you see a marked difference between the A11 in blue and the A69 in orange. Okay, so defining response to antibody reduction strategies is limited when you only consider serum in its neat form, and this is just a very basic illustration. All right, so then defining the titer for each specificity. So evidently there are many different specificities in this multiplex assay, and so what you can then do is essentially get the MFIs for each individual specificity, and then you identify the MFI where you hit that inflection point. So if we look at the B52, I don't think I have a pointer here, but the B52 on the first line, you see that it goes from 3,500 at 1 in 256 down to below 1,000 at 1 in 1024. And so we call the titer here 512, or 1 in 512, and that's because it's the intermediate titer in between 256 and 1024. If we look, and so then when we calculate the CPRA, at a titer of 1 in 512 or lower, you're going to include B52 in that CPRA calculation, whereas if you're above that, you will not. And so that's what I'm talking about when we're talking about calculating a CPRA in titer. Just to give a slightly different example and complicate things a little bit more, if you look at the B13 at the bottom, at 1 in 64, it has an MFI of 1,700, and at 1 in 256, it's down to 400. And so for this, the way we designed our calculation matrix, so to speak, the CPRA at 1 in 64 and lower would be included, while above at 1 in 256 and above, it would not. So the CPRA, this is just basically to say that if you do this for every single bead, you can calculate a CPRA in titer. And this will be relevant to some of our discussion later on. Okay, and this just shows why this is relevant. This is work by Anat and colleagues. If you look at all 20 patients listed on the y-axis, with the titers being on the x-axis, what you can see is that at a neat serum, all the patients look identical. They all have a CPRA of 100%. But if you just go to the middle of this graph and walk to a titer of 1 in 64, 1 in 256, you can really understand the heterogeneity of this patient population. And so when you start talking about desensitization efficacy and you're only looking at neat serum, I think it's just logical that you cannot expect to see the same response in neat serum for all of these patients. Okay, so what have we been doing? So first we went back and did a literature review since the last STAR to see how the field has changed. Of course, acknowledging that most of the studies coming out would have been planned more than 5 years ago, so it was more a matter of how are the papers written. Second is, what is the state of the field? What are the ongoing trials, and what kind of definitions are they looking at? Also acknowledging that many of these clinical trials were planned more than 5 years ago. And then finally, we went ahead and did a wet lab component where we have asked whether or not we can begin to validate some of the recommendations from STAR 2022. So just to briefly summarize the literature review, which we discussed a little bit more extensively during the webinar back in October, we identified 27 studies, of which 7 were prospective interventional studies, and those are really the ones that we focused on. 5 were in kidney, 2 were in heart. And the key points that we were looking for was methodology. Were the papers indicating specific time points for looking at the antibodies, and were they using strategies to reduce, for example, proson or saturation? And in terms of what we were looking at, inclusion criteria, it was most commonly CPRA. And then for the endpoints, although there was quite a bit of heterogeneity in the actual endpoints, what we were looking for was whether or not there was an attempt to sort of address this concept very broadly of antibody strength, either by looking at multiple MFI thresholds or by actually using CPRA in titers. Some sites also use the C1Q assay, and then, of course, clinical considerations. And so to sort of summarize what we found, the methodology, there's been marked improvements, and we were quite happy to see that almost all of the papers indicated strategies to address proson and or saturation. And then in terms of the endpoints, I've already sort of alluded to the fact that there was heterogeneity, but really there were quite a few endpoints being addressed, and so you could see that there was already an attempt at trying to get at this concept that patients are heterogeneous, the serums are very different, and we need to acknowledge some of these differences. And in particular, there were 2 papers that actually have started to use CPRA in titer. Okay, what about ABMR? So there were 21 studies, 14 of which were kidney, 6 were prospective interventional, all in kidney. And I'm not going to say a lot about this. The endpoints were still really mainly a change in immunodominant DSA, supported by a lot of histology and some clinical outcomes. And I think this is a field that reflects that there's even more uncertainty as to how to specifically address immunodominant versus total antibodies, and just a lot of unknowns still. And then in terms of sort of just a summary here, what we really came up with was that there has been increasing rigor in the description of antibody testing methodology. In terms of the antibody reduction or desensitization strategies, most studies included at least more than one definition of antibody response, which we thought was very encouraging. In terms of ABMR, as I've already mentioned, DSA, MFI conversion, and immunodominance were still sort of the most common. So with that, what's the state of the field? Where are things going? What are the ongoing clinical trials? So we identified 26 trials in total, of which 24 were kidney transplant. Of those, we excluded those that had an unknown status and those that were not dealing with HLA antibodies, giving us a total of 16 studies, of which 2 were purely mechanistic, and so we had 14 with clinical endpoints. In terms of inclusion criteria, not surprisingly, CPRA was still the most common. And then in terms of endpoints, I just want to highlight here that these endpoints are taken from clinicaltrials.gov, and so things like, for example, titers that may be included as part of methodology are not necessarily reflected here, but I think you can still see a lot of heterogeneity in the type of endpoints that are being evaluated, with MFI and immunodominant antibodies still sort of leading the field. So it'll be interesting to see the outcomes of these trials and sort of how they are interpreted. Again, remembering that these trials were all planned quite some time ago. So just in summary, from our literature review, I think we agreed that there was increased awareness of the need to consider the concept of antibody strength and significant improvements in the methodology of reporting. But that we still need quite a bit of work to enhance study-to-study interpretive value. In terms of clinical trials, I think the endpoints reflect the enhanced awareness that we need to consider antibody strength, but they are still quite heterogeneous, leaving us with questions about how we're going to try and synthesize all of this data together. And I'll just put out there that there's a limited number of studies outside of the kidney world, and so these will require organ-specific considerations, but I think that since kidney is such a large part of the transplant field, for those of us who work outside of that space, if there's core antibody strength assessment strategies that are used in the kidney trials and we can clearly interpret it, then we can also contextualize it within all the other organ systems. So I think this is really, really important. So now I'm just going to turn to our wet lab, which was named Harmonizing Efficacy of Antibody Reduction Therapies Using Titers. So why did we design this study? Well, I think I've already alluded to much of this, but the use of titers to harmonize interpretation of antibody strength across centers has really not been validated. And so the first question we just wanted to ask as an overarching theme is, can we agree on interpatient heterogeneity in sensitization phenotype? And I'll give you an idea of what we're calling phenotype on the next slide. We already know from important work that has been done by others in this room that standard operating procedures reduce variability between centers. What we also wanted to know is what are the characteristics of antibody assessment when we start using these dilution series and titers under standardized operating procedures. And then finally, whether titers can improve standardized assessment of how patients are actually responding to treatment across different centers has really not been established. And so the first question that we just wanted to ask is, can we agree on whether a patient has or has not responded to treatment at different centers? So here's what we did. So we designed a multi-center study to evaluate the use of these titers. It was a harmonized collaborative between 5 sites across 2 continents. So we had PIs in Barcelona and Nantes, as well as 3 here in the US, Georgetown, Northwestern, and UPMC. We picked 10 heterogeneous cases that were evaluated before and after an intervention to reduce circulating antibodies. And I want to highlight here that we were completely treatment agnostic. So the purpose of this was not to evaluate any therapy. The purpose of this was to say, if we take random cases across different centers that have very different treatment protocols, can we get some kind of agreement? And I want to highlight that reagents were provided by both Thermo Fisher and Werfen. In terms of harmonizing the protocols, we got together and collaboratively established harmonized protocols for both of the vendors. We tried to use the same kits. There was a slight variation for 2 of the European kits, but otherwise everything was the same. Every site received an aliquot from the same EDTA, same positive controls. We had very extensive protocols written out and standardized plate layouts. And then we just essentially performed our analysis at NEAT and in 4 dilutions. And so you can see the math there, but essentially there were a total of 200 samples analyzed. From, just to be clear though, from 10 cases over 2 time points. Okay, so now getting to these 3 overarching questions we had. Before I get there, in terms of defining a sensitization phenotype, so this is something that we've been talking about a little bit. I'm just going to give a representative. So this is a single case here of one patient's multiple class 1 here antibodies. And what you can see is that there's sort of a almost linear progressive decrease in MFI with each dilution. And so we define that as sort of one phenotype. But then there's this other phenotype where you see a plateau across dilutions with persistent bead saturation, at least in this case, out to about 1 in 16. And so now what I'm going to show on the next slide is just a proof of principle of representative specificities. And so now instead of showing all the different specificities, in this graph, we're showing the 5 sites with 1 specificity. And what you can see here is that all the sites had a general agreement on this progressive decrease in MFI, or this type of an antibody phenotype. And similarly, using a different specificity, all 5 sites showed this sort of plateau across dilutions, even though the absolute MFIs, of course, were quite different between some of the sites. Okay, so with that concept, I'm now going to move on to a slightly more quantitative one, where we go back to the different titers. And what we were wanting to ask are, what are the characteristics of antibody assessment in these titers under standard operating procedures? And so just to highlight here, the interpolation of titers in between the different titers that we actually performed. I've already gone over that, so for the sake of time, I will keep going, except to remind you that the titer is defined for each specificity, and then the CPRA is defined at each titer. And so I just want to introduce you to this graph, which essentially on the x-axis shows the CPRA, and on the y-axis we have a double axis. So we have our titers, neat, 1 in 4, down to 1 in 256. And then we have a secondary axis on the y where we have the 5 different sites. So each green dot at each titer represents a different site. And then on the right-sided axis, we have the coefficient of variability, which in this particular case you can see is very, very nice and tight and small. And this individual, or this case, you can see had a very high CPRA down to a titer of 1 in 64, where it then started coming down. Okay, so that was just to introduce you to the overall plot. Here's the same plot. And here's a second case where you can see that the individual was not as sensitized, and that there was considerably more variability with the centers with a much larger coefficient of variability. And so if we look at the coefficients across all 10 cases from the sites, I put this here only to highlight one thing that I think is important as we move ahead and talk about the rest of the points here, is that as you go to the higher dilutions, you can get very, very, very large coefficients of variability. And one of the key things that we need to think about when we're using CPRA is that CPRA is the product of a standardized test where we already know that there's some variability and allele frequencies in the population. And so when you look at, case 8, where you see an 82% coefficient of variability, that's probably not representing an issue so much with the standard operating procedures as the fact that it is because we've defined an arbitrary threshold, and then we are using alleles that are likely high frequency in the population. And so even if the sites have relatively good maybe not analytic variability, but essentially coefficients of variability in their beads, they can get dramatically different results. So I just want to highlight that caveat. And so from there, although we're not making any final recommendations, I think the point that I'm trying to make is that the titers may actually provide us with a harmonized phenotype of the patient, but this variability, small variabilities are going to be amplified by allele frequencies in the CPRA. Okay. So now the final third pillar here, can we agree on whether a patient has or has not responded to treatment? And again, these are very, very preliminary, but I just wanted to highlight some of the things that I think we're all thinking about. So if you take this same kind of graph, each line in the same color is one of the 5 sites. So in blue, we see the pre-treatment, and in orange, we see the post-treatment. I think we can all agree that there has been some sort of a response to treatment, which is roughly larger than 50% in neat titer, or in neat dilution, or non-diluted serum. Okay, so then if we go back to our patient who had a very plateaued, high titer saturated antibody here, and we look at the sites, what we would say is that essentially without diluting, there was no response. And even if you go to 1 in 16, you would probably conclude that there's no response. But if you go out to a titer of 1 in 256, you again see that you get almost a 50% reduction in MFI. And so both of these patients responded to the intervention, but then the clinical relevance is going to be context specific. And I think that this point about clinical relevance being context-specific is going to become increasingly more important as we develop more and more potent antibody reduction strategies. And thinking about also how this might impact post-transplant management is a completely unknown field to us. Okay, so just a little bit more about this. Again, just to remind you, there were 10 cases, 5 centers, NEAT, and 4 titers. What I'm now showing is the same type of a graph, except that on the x-axis we have the delta reduction in CPRA, with reduction actually going to the right. So what you can see here is that if we take those same 2 cases that I showed you earlier, there's a significant or a marked reduction. I won't use statistics here because it's a pictorial, but you can see that both of these patients responded to the antibody intervention, but the maximal response is seen at different titers for both of these patients. So I just want to highlight that and highlight the fact that, again, when you use CPRA that is also affected by allele level frequencies, you're going to see quite a bit of heterogeneity. But can we still make something of that? So this is some additional work that was done here. What you see is now for each of the centers represented on the x-axis, the mean CPRA of the 10 cases on the essentially being represented by a line at each of the different titers. And what I just want to highlight here is that before the intervention, you can see that NEAT 1 in 4 and 1 in 16 all cluster really closely together. And then what you see here is that they've spread much further apart. And so although it may not be absolute differences that are consistent, I think what you can see are these consistent trends. And how we use this data is going to be incredibly important when we start thinking of how we design future studies. And the relevance thereof is also going to be highly clinically, going to need highly nuanced clinical contextualization depending on what we're wanting to achieve. So in this final slide, I want to highlight a potential adjunct that we did only at one site, and we wanted to look at flow CPRA and whether there was additional information we could get from this or whether it was largely the same as from our single antigen bead dilution. So what we did was we performed the flow CPRA in titer as well. And so this is the baseline, and just to orient you, the negative control is in this sort of neon green, and the case or the patient is in red, and I've just shown here 3 representative plots, NEAT 1 in 16 and 1 in 256. And I think you can see the expected reduction in serum MFI. But I think that this is really interesting here because if you look at the single antigen bead CPRAs, you see 2 things. Firstly, between the first and second plots, I think that the difference is much more clearly seen with the flow CPRA. And second, between the second plot and the final plot, you see that even though the CPRA was sort of arbitrarily indicated as 0 based on these MFI thresholds, there is in fact still likely a significant net threshold of antibodies, shall I say here. So after treatment, what happens? I think you can see that perhaps between the 1 in 16 and the 1 in 256, you see a marked response to treatment. Again, it doesn't necessarily correlate with the single antigen bead, but there is definitely a significant trend. And I will just mention that in terms of that 0% CPRA at baseline, in the upper right-hand corner, there was quite a bit of variability between the sites as to what the actual CPRA was with the single antigen bead. So this is definitely not ready for prime time yet, but what we wanted to do was put it out there as a potential adjunct. And so with that, I'm just going to summarize and say that our working group worked across 2 continents to address some of the recommendations from STAR 2022. We had 3 overarching objectives related to sensitization phenotypes and quantification of antibody responses that I've just taken you through. And I think that although we are not making our final recommendations right now, it was very encouraging to see that there are some consistent trends, but also the expected heterogeneity. And so adjunctive strategies may enhance interpretive value. That's something to address in the next few years. And so I'd just like to acknowledge everybody, especially the site PIs who were participating in this, our industry sponsors, and of course, AST. Thanks.
Up to questions for the audience. We have about, I think, 12 minutes of questions. I want to make sure that everybody has time for a little break before we get started again. But let's start with a question from the audience.
Yeah, so that a nice talk. So one of the slides you show that 2 serum, one B2705, other one is 1101 serum. You know, the B2705 is a nice reduction in dilutions, but other serum 1101, you see a difference. You know, so some specificity stays there, some goes there. I'm wondering whether it's the B2705 serum is the BW4 specificity in terms of the global specificity, because BW4 is a single antibody, and when you dilute it, can clearly see a stepwise reduction, but in other serum 1101 that belongs to cross-reactive group 1 that comprise A1, 11, 3, 19. So the different subset of antibodies, whether that causing a problem. So I think my question is, did you look at how the serum behave based on different cross-reactive groups?
Well, I'll let Anat talk more, but the bottom line is, at this point, no, we were using individual specificities, but I think the point that we were trying to get at is that both antibodies responded by 50%. It just took a much further titer to see that response. So I think your point is well taken, and I'm sure that we will consider this more in our final analysis, but the purpose of that specific slide was actually to show that the response was identical for both of them.
Let me just maybe reiterate the point that we are in the midst of doing the analysis. The point of presenting some of the data here today was really to give you a sense of what we're trying to do. And yes, we definitely have a lot of patients with different CREGs antibody over the thing. I think to Marlena's point, which is really, really important, when the vast majority of the centers, when they're reporting DSA, they're using the particular specificity rather than putting it in the context of a CREG, which is something else that we definitely need to go. But yeah, be on the watch out. We are, I'd say, relatively early in the analysis process. There's a lot to come from that study, and we're hoping to publish it out there. Maybe just add two things of clarity. Everyone who knows me know I'm a huge stickler for words, so I really would encourage everyone to distinguish between titers and dilutions. Doing dilutions does not necessarily mean that you have a titer, and Marlena had highlighted this, but a lot of people in the field use this kind of interchangeably, so I think that's an important thing. And lastly, for the last 2 slides that Marlena had showed, just a quick correction, this is not flow CPRA, it's just a flow PRA. We do not make the calculation. So if anyone in the HLA community here was asking what that is all about, that's the point. But thank you, Marlena.
Very quickly, I just wanted to say I was glad to hear that when you went back and reviewed the literature since the last iteration of STAR, when we made these recommendations, that you saw that there was more rigor in describing the methods. Actually, ASHE had published as part of the STIC committee in, I don't know how long ago that was that we did that, but a minimal reporting standards that seemed to just fall flat and go into the abyss. So it sounds like STAR had some more success in that. And I have to just say that is part of a push by editors and reviewers to ask for those things in addition to the authors being aware of them themselves. So if you're asked to review and you don't see that methodologic rigor in the publication, please ask for it in accordance with the STAR.
Yeah, thank you, Nicole. This is a really, really important point.
No, and I want to, Anna.
Hello? Yeah, okay, thanks. I have a question. We have anecdotally found that some of our patients, if we do a 1 in 10 dilution prior to desensitization strategy, we can kind of predict how they're going to respond a couple weeks after transplant or after desensitization starts. So do you have any idea for if titer could be used for a strategy to predict response for patients post-desensitization?
So my theory on that is that the response depends on what you're treating with, and it depends on how hard you're going to hit. And so I don't think that we can do that. I think that has to be a site-specific or a protocol-specific question, and I think that's where the clinical side and the interpretable side of the actual assay itself becomes extremely important, because if you're going to do a very sort of basic desensitization strategy, then I agree, you need to know what the potential value of your treatment strategy is going to be. And if you're not going to get that result, then there's actually no point in you subjecting the patient to that. On the other hand, if you're asking how far can I push, then that titer is going to dramatically change.
If I can add to this, at Northwestern, we had the experience of working with kidneys, not with hearts, and doing plasmapheresis IVIG in preparation for a living donor transplantation. There's a paper by Dave Pinelli that is out several years ago that we showed, and especially for this particular treatment modality, that is important to show. Once you try to go beyond certain amount of plasmapheresis IVIG cycles, you start getting what we refer to as diminishing returns. There's a maximum reduction of the level of antibodies. We at the time kind of put our bar at around a titer of 1 to 64 or a titer of 1 to 128, and I know our clinicians will not even start desensitizing someone if the titer of the potential donor DSA is above that, because we are not successful. We actually worked with Bob Montgomery at the time and reproduced pretty much the same data, again, very, very specific for plasmapheresis IVIG, and I don't think that can go across different studies. I think the important thing, and this is a study that we've done with Carrie Shinstock and Mark Stigl, and I don't know, Carrie, if you would like to add that, but the vast majority of our patients obviously don't have a living donor, and the idea was, of those really highly sensitized patients that we want to try and desensitize, can we predict who's more likely to respond and who's less likely to respond? To Marlena's point, probably you will be or not find something that would reduce a particular antibody to a particular level, and I'm not going to go into theories here, but at least you can divide your patients to those that are more likely to respond sooner compared to those that would not respond relatively quickly, but I'll let the clinician answer.
Yeah, no, and I think it's been helpful in our practice. It really illuminates that the 100% CPRA patients are very different. This is such a heterogeneous group. It helps us to know who we can find therapies, who we can predict that even if we put them in a KPD program, that if that we're likely to find something with that we're able to work with. So I think that's another kind of side point that we'll take away as clinicians, that this can really help us better understand those 100%ers, and also maybe eventually take that for policy in allocation potentially of how we can better, because they're not all those patients are not all the same.
And I think that it also is going to start playing a role as we start to nuance the post-transplant care and the types of therapies that we're using post-transplant in the early versus the longer follow-up time points. And I think it's a completely unknown field how we use the ease of, or lack of ease of changing antibody titers, let's say, or dilutions, which actually it would be titers, with a therapeutic intervention before transplant, how that affects what we do in the early postoperative period.